ooh, 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 ooh.
It's always exciting to get to the end of a chapter, isn't it? Except then you realize, uh-oh, the end of the chapter means application time, word problems. I don't know why it doesn't say applications this time, but that's what it says in your workbook, so that's what I went with. Okay, so what we're going to be looking at with these applications is harmonic motion. It sounds beautiful. And what harmonic motion is, it's a motion involving a pattern that's repeated at fixed time intervals. So it's a motion that repeats over and over and over and over. What kind of things repeat over and over and over? Things like a Ferris wheel, right? You go up, you go down, you go up, you go down. The tides, they go out, they come in, they go out, they come in. Springs, like you pull a spring down, then you let it go, it goes up, goes down, goes up, goes down, goes up, down. Radio waves, the amount of daylight, right? Throughout a year, there's more and more and more daylight, then less and less and less daylight, and then more and more daylight, like that. Okay, so these are the sort of questions we're going to do. Now, the two classics that occur in every single math textbook ever made to man, I think, are the Ferris wheel and the tides. So we will definitely do one example of each of those. So here's our Ferris wheel example, and on the other side of the page we've got our tides question. So here we go. A Ferris wheel has a radius of 20 meters. It rotates once every 40 seconds. Passengers get on at the Ferris wheel's lowest point, which is 1 meter above the ground. Graph how a person's height above the ground varies during the first 2 cycles. Okay, we're going to do very, very simple graphs with these. What I want to do is just to think about maximum and minimum. And then maybe I'll also draw somewhere in the middle here that center point. Ignore that arrow, would you? Okay, so people get on at the lowest point. So this is like our lowest point down here. So let's call that 1 meter because that's how high it is. So 1. Now the radius of the Ferris wheel is 20. So when you're up at the top, what's the highest it could be? Let's just draw the Ferris wheel out here for a second. If this is our Ferris wheel and this distance here, the radius is 20, then when you're way up here at the top, well, there's another 20. So your height way up here is 40, but remember, this thing's off the ground a little bit, right? The Ferris wheel is a very advanced Ferris wheel here. This distance from here to here is 1 meter. So when you're way up at the top here, you're 20 plus 1, you're 41. So the height at the very, very top here is 41. That's the maximum height someone reaches. And what else? Oh, we want to know the center line. Well, to get the center line, that is right in the middle of 1 and 41. So the way you can do that, if you can't figure it out, is you can add the max and the minimum together, 1 plus 41, divide by 2. I'll give you the answer. So 42, divided by 2 is 21. So this here is at 21. And then basically what happens is that person gets on, time 0, so this is time down here, right? Here's time. This is height. They get on at time 0 and the ride starts and they go up. And then they come back down again. Then they go up again. Then they come, guess I should make it actually go up as high. We don't want the Ferris wheel having some kind of mechanical difficulty. Goes right back up again and then it comes down. Now I know it's not a very good graph, but it gives us a sense, it gives us an idea, and we can actually figure out almost everything we need, because in the equation, remember when we have these fancy equations, we have y equals a, then we have either our sine or our cos right there, then we've got a b value, then we've got x minus c value, and then we got d. So what we really need to do is we need to figure out what's our a value, what's our b value, what's our c value, what's our d value, and are we going to use sine or cos? Sounds like a lot, but believe it or not, we actually have a lot of that information already. For example, what's the vertical displacement here? If you think back to sine graphs and cosine graphs, where do they usually have their center line? They usually have their center line right along the x-axis. Where's this one have its center line? At 21. So the vertical displacement, which is equal to d, remember, is 21. Finished. Okay, let's talk about amplitude. Amplitude is the distance from the center line to the maximum or to the minimum point. So the amplitude is the distance from 21 up to 41, or the distance from 1 to 21. Either way, the amplitude is 20. And what's more, amplitude is equal to A. Well, almost. It's equal to the absolute value of A. So that means that our A value is either 20 or it's negative 20. Okay, so we already have that figured out quite a bit. Next, let's figure out the period, because that'll help us get B, right? What's the period here? How long does it take for this thing to start repeating again? Well, if I look, this thing goes up and down, and it starts going up again right here. So I want to know how much time that was. What does it tell us? Must tell us something. It rotates once every 40 seconds. Well, there you go. From 0, it rotates all the way around once you get to 40 seconds. So the period is 40 seconds. However, we don't want to know the period. We want to know what the B value is. Well, remember, period is equal to 2 pi over the absolute value of B. So 2 pi over B has to equal 40. And if we put that over 1 and cross multiply, you get that 1 times 2 pi is 2 pi. 40 times B is 40B. And then if you divide by 40, you get B equals 2 pi over 40. Let's simplify that to pi over 20. So our B value, B equals pi over 20. Okay, this will leave us with two last things to find. We have to figure out, are we going to use sine or cosine? And we have to figure out, is there any horizontal displacement here? Is there any, not displacement, is there any horizontal translation here? Is there a phase shift in this case? Let's start with sine or cos. So I want you to think of something here. With sine, remember with sine, what happened is it started right at the center line, which was the x-axis in the mother function, and it went up, and it went down, and it went up, and went down. This was sine. That's if it starts at the mother function, or the center line, and goes up. In the cosine graph, remember, it started up here at the maximum and went down and up and down. This was cosine. So that's a possibility. How would we make it do something like we have here, where it starts down here at a minimum and it goes up and down and up? Well, that's exactly the same as the second one, except it's flipped over. It's reflected across the x-axis. So what would make it reflect over the x-axis? If it was negative cosine. The last possibility, I suppose, would be if center line, but instead of starting at the center line going up, it starts at the center line goes down. What would make it do that? That's the opposite of the sine, right? Starting at the center line going up, starting at the center line going down. This is a negative sign. So it's best, I think, to choose which one of these graphs here, these four possibilities, which one of them looks closest like this? Well, in this case, you're starting at a minimum and you're going up. That definitely looks like this. So I think the smartest thing to use would be a negative cosine graph in this case. Now, you don't have to, and I'll show you that in a second, but I think it's the best case here. So let's start filling stuff in. I know we haven't talked about the C value yet, but let's start filling stuff in. We have y equals A. We said A was 20 or negative 20, because remember, amplitude is the absolute value of A. And we want to have a negative cosine graph. So it must be negative 20 cosine. Then we put in our B value, which we know is pi over 20. Multiply that by x minus, now we have x minus c. Well, x, we're going to call it time, so let's call it t. Has this thing been shifted over at all, or does it actually start right at the minimum? It actually starts right at the minimum, so we don't have any phase shift here, right? If this graph started over here at 2 or something, and then did this, we would have a phase shift of 2. But we don't have a phase shift here because it starts right at the minimum value. So that's great. No phase shift. So you don't need to put a C value in there. C value is 0. And our D value is 21. And we're finished. Okay, that's the answer right there. Now, that's not the only answer. What if you did want to use a positive cosine graph? Say you wanted to, you said, I don't understand this negative cosine graph. I want to use a positive cosine graph. Well, then you'd want to look, where is it in this graph here that we drew, where is it that it starts looking like this? Like, where's the first time you have a maximum and it's moving down? Oh, the first time you have a maximum and it's moving down is right here, isn't it? This point right here. So you'd want to know, well, what's that point? How far over is that? Well, I know I haven't drawn it very well, but if this minimum's at 0 and this minimum's at 40, where must the maximum be? Right in the middle. This must be at 20. So another way you could write this, it would no longer be a negative cosine. It would now be a positive cosine because it looks like this, starting at a maximum, moving down. You could put y equals, still 20, it's not negative this time, but still 20, cosine, still have pi over 20, that stays the same. Okay, this is going to be a little different. It's going to be t. Now, how much have you had to move the graph over? What's the phase shift here if you're going to start at this? You had to move it over 20, so it's t minus 20 plus 21. So this works as well. It's actually the same graph. If you were to graph both of these in a graphing calculator, they look exactly the same. Remember I told you this, there's infinite equations for this. Let's do another one of these. Let's do a sine one for this. You don't have to do this. You only have to get one, right? And I think this first one is the most sensible one. If we want to do a sine graph, you'd be looking for where's the first time that we have a point where it's at the center line and then moving up. Oh, the first time we have a point that's on the center line and then moving up is right there. Now, how much must that be? Well, if a minimum's at 0 and the maximum's at 20, halfway between it must be at 10. Okay, we're good to go again. So this is a positive sign because it's moving up from the center line. And it would be y equals 20 again, that stays the same. This time it would be sine, still have pi over 20, but this time it would be t take away, we moved over 10, so t minus 10, and you still have plus 21. If you wanted to, you could do it for negative sine. I don't know why you would, but that would be from this point. So it would be the same thing, except you'd have it shifted over to negative 30 and you'd use negative sine. You could also have started at here, right? You could do the same graph, exactly the same graph here, but you could put, instead of just having t here, you could put t minus 40, because if you shift the whole thing over to 40, you get the same thing repeating. I'd be a bit weird, but my point is there's all sorts of ways of doing this. I think this first one's the simplest way to do it. Okay, that was a lot of talking for one question. C. Question C is, estimate the height above the ground after 45 seconds. Alright, well you could use any one of these graphs. I'm going to use the first one that I talked about it here. I'll highlight it, this one. And we want to know how high you are after 45 seconds. I suppose if you want to do this very, very, I don't know what the word would be, nicely or mathematically or whatever, instead of calling it y, you might want to call it h for height, h for height, h for height. Okay, I'm not going to take any marks off for that kind of stuff. So I'm kind of rambling here. 45 seconds. So you're going to put 45 into the height or the time? Well, 45 seconds of time, so you're going to put in there. So h equals negative 20 cosine pi over 20 45 plus 21. You're going to pick up your calculator and you're going to do this. Now, before you pick up your calculator, make sure calculator in radians. It must be in radians. If you don't know how to switch your calculator to radians, come and see me sometime. I'll try to figure it out for you. Okay, so what I would do is I would start by doing 45 times pi, then I would divide by 20, then I'd find out what is the cosine value of that. So that leaves me with h equals negative 20, and this whole amount, I took the cosine of that highlighted amount. What I get there is 0.7071. Don't round it off too quickly. Do 3 or 4 decimal points. Then plus 21. So then I'd multiply that amount by negative 20. That 0.7071 times negative 20. And then I would add 21. And if you do that, you should get an answer like 6.9 meters. Okay, D. Now, D is a little more difficult. It says, estimate one of the times when a person would be 35 meters above the ground. 35 meters, so, it's somewhere around, I don't know, somewhere around here. So you could make a very, very rough estimate by looking at the graph. Oh, 35 meters must be somewhere around 15 seconds and somewhere around 23 seconds and somewhere around like that. You could get a much, much, much more accurate, very, very accurate by using your graphing calculator. That's probably what you would do here. But I just want to show you how you don't actually need to use your graphing calculator. If I want to know when it's going to be 35 meters above the ground, I put 35 into height, so I get 35 equals negative 20 cosine pi over 20 t plus 21. Okay, now I want to isolate this t, don't I? So let's start by bringing the 21 over. So you get 14 equals negative 20 cosine pi over 20t. Next thing you do is divide by negative 20, so you get negative 0.7 equals cosine. Why don't we figure out what pi divided by 20 is? So it equals 0.157 t. So now we want to isolate this t. We want to do the opposite of cosine. What's the opposite of cosine? Inverse cosine. So we want to take the inverse cos of each side. So we get cos inverse of negative 0.7 equals, and all you'll be left with over here is 0.157 t. So take the inverse cos, shift cos or second cos or whatever it's called in your calculator, of negative 0.7, and I get 2.35 equals 0.157 t. And then if I divide both sides by 0.157, I will have my answer, and I get the answer 14.9. So after 14.9 seconds, the height of the Ferris wheel will be 35 meters. Okay, now this sort of thing here, if this confuses you a little bit, don't worry about it. I don't think I ask you to do any of those in your homework. I won't put, well, maybe a bonus, that might be a good idea. But we'll be learning how to do more of this when we get to the next chapter. Okay, I just want to show you how you don't need to have a graphing calculator to do this. Okay, next question. Talking about tides this time. So let's start by putting our lines in here. So this will be good for the maximum, this will be good for the minimum, somewhere in between. One have a dotted one for the center line. I mean, you don't have to do them dotted, you do what you want. On a typical day at the ocean port, the water at an ocean port, the water has a maximum depth of 20 meters at 8 o'clock a.m. So it's going to be at its maximum depth, which is 20, at 8 o'clock. 8 o'clock. So this is time, and this is depth. The minimum depth of 8 meters, so the minimum it goes to is 8, occurs 6.2 hours later. Well, 8 plus 6.2 equals 14.2. I know when we're talking about time, you might want to change that to 2 o'clock in the afternoon, but I think it's easier if you keep it 24-hour clock. So let's make this 14.2. Okay, so this is the maximum, so it's going to come down to this minimum, and it's going to go back up again and down again, etc. like that. We could also keep drawing it like this a little bit if we want. It's just terrible, terrible, terrible. I know. All I'm trying to do is give us a sense here. Okay, well, what else can we figure out here? Well, the first thing it says, what's the period? So the period, this was at 8 hours. This was at 14 point hour. Is that the period? No, it hasn't come back up. We have to go all the way back up to here. So what's the period? Well, if it was 6.2 hours from here to here, it must be another 6.2 hours to here, which gives us a total of 12.4 hours is our period. Oh, that was easy. Okay, B. Now we want to figure out all this stuff. So first thing we can figure out here is what's the vertical displacement? In other words, where's the center line? Okay, well the center line is right between 8 and 20. So 8 and 20 and divide it by 2 is 28 over 2, so it's right at 14. Okay, so that's our D value. D value is 14. What's our amplitude? The amplitude's the distance from that center line up or from the center line down, so either way it's 6. So the amplitude is equal to 6, and that's equal to A, absolute value of A. So our A value is either 6 or negative 6, depending on whether we pick a positive sign or a negative sign or a positive cos or a negative cos graph. Okay, next we can figure out the B value, because remember, we've got the period, this is the period up here, period, or 12.4, equals 2 pi over b. So if you put over 1 and cross multiply, you get 12.4b equals 2 pi. Let's divide by 12.4. You get b equals 2 pi over 12.4. That's good. Or we could divide both of them by 2, make it a little simpler. Pi over 6.2. Let's do that. Okay, we're ready. Now, again, you have to decide which sort of graph you want to use. Since they talk about this value first, this 8, maybe we want to use this point. Let's use this as our starting point right here. Okay? So if you're going to start there, that's starting at a maximum and moving down. Which one of the graphs would we use if we're starting at a maximum and moving down? That sounds a lot like this graph, starting at a maximum and moving down. That's a positive cosine graph. Alright, so what we have then is y equals, or maybe instead of y, what are we talking about here? Depth. Okay, d equals, I guess, for depth. D equals the a value, and we said it's going to be positive cosine graph, so 6 cosine. The b value is pi over 6.2 time t minus, now how much has this thing been shifted over? Well, we shifted this over to 8. We're starting not at time 0, we're starting at time 8. So it's t minus 8, and then our vertical displacement, our d value is 14. Finished. That's it. Okay, if you wanted to, you could do different graphs for this. I think one nice one that you might want to have done is if you'd followed this back to here, to this point here, what value is that? Well, it was 6.2 to this and 6.2, so it must be another 6.2 back here. So this point here is at 1.8. So this would be a pretty nice one to use because it's a little earlier in the day. Rather than starting at 8 o'clock, you can get it back to 1.8 o'clock, whatever time that is. So which graph would you use there? That's starting at a minimum and moving upwards. Starting at a minimum and moving upwards. That's this one, negative cosine. So you'd have everything the same except for two things. One would be, or we could have d, instead of having positive 6, we'd have negative 6 cosine pi over 6.2 t plus 14. Now it wouldn't be minus 8 anymore. How much did we move it over to get to that point? We moved it over to 1.8. So it'd be t minus 1.8. If you wanted to use a sine graph, if the question said you must use a sine graph, this would be your magic point right here, because this is where it moves up away from the center line. What point is that? Well, it looks like it's right between 1.8 and 8. So you could get what the average is between them, or instead of adding 6.2, add half of 6.2, add 3.1. Anyway, you'll figure out that this point here is at 4.9. So why don't I just write it down here? I believe this is the one that was in the textbook answer. From the textbook I got it. I don't like it as much, but that's a positive sine graph, so it'd be 6 sine pi over 6.2 t minus 4.9 this time. It's 4.9 away from 0. Plus 14. Okay? Hopefully you're getting the idea how there's a whole bunch of different equations that describe the same thing. You just have to figure out which part am I going to start my equation from. Okay, C asks you, what would be the depth at 10 o'clock in the morning? So I'm going to use my first graph up here, the one I initially came up with. And at 10 o'clock, well, that's a time, so I'm going to put 10 into t. So I get d equals 6 cosine pi over 6.2, 10 minus 8 plus 14. And I pick up my calculator and I just start plugging all this in. I get 10 minus 8 is 2. Then I go 2 times pi. Then I divide that answer by 6.2. And then I take cosine of that. Just, I guess if you want to try this at home, might be a good idea. I'll figure out what the answer is to that and write it down. That leaves you with d equals 6. All this highlighted part is 0.529. Plus 14. So you're going to multiply that answer by 6 and add 14, and you should get an answer of 17.2 what is it, meters? Meters. 17.2 meters is your answer. And the final question is the difficult one again. We want to know, estimate one of the times when the water is 10 meters deep. So The depth is 10, so this time we're plugging 10 into that big D there. So we have 10 equals 6 cosine pi over 6.2 t minus 8 plus 14. First thing I do is move 14 over, and you get negative 4 and divide by 6. Anyway, you can do that yourself. Subtract 14, divide by 6, you get negative 2 over 3 equals cosine. Let's figure out what pi divided by 6.2 is. If you divide pi by 6.2, you get 0.5067 t minus 8. Now we want to get rid of that cosine, so we have to do the opposite. We have to take the inverse cos of negative 2/3, and that'll leave us over here with just 0.5067 times t minus 8. Inverse cos of negative 2/3 is about 2.3 equals 0.5067 t minus 8. Divide both sides by 0.5067, just doing simple algebra now, right? You end up with 4.54 equals t minus 8. And the last step, you're going to add 8 to both sides. You're going to end up with an answer to like t equals 12.54. But what does this answer mean, 12.54? Remember, this time 8 was 8 o'clock a.m. And this time here is 14.2 hours. So this time here is 12.54 hours. But we don't talk about, oh, it's 12.54 o'clock right now. So it's obviously 12 o'clock and something. So it's a little, I don't know, little glitch with this one question, these time questions. If it's 0.54 hours, you got to figure out how much of a full hour is that. In other words, you got to figure out what's 0.54 of, that means times, right, of the full hour, and a full hour is 60 minutes. So you got to figure out what's 0.54 of 60 minutes, because that'll tell you how many minutes the 0.54 hours is. I'm switching this 0.54 hours into minutes. And when I multiply 0.54 times 60, I get 32.4. So totally, our final answer is 12 o'clock and 32.4 minutes. Let's just call it 32 minutes. So the depth of the tide, or whatever we're calling it, is at 10 meters at 12:32 p.m. I suppose. Okay, got to be careful of those time ones when you have to do the little multiplying at the end. Okay, that's it. We have now reached the end of chapter 5. More trigonometry to come in chapter 6.